This is the add numbers.c file which we created in the previous lectures. What I want to do, and we said that it adds two numbers, what I want to do is to, instead of creating the process directly which we were doing before, I want to do the steps one by one, which we said there are a couple of steps like compiling, assembling, and linking. I want to do these steps one by one and see the changes. So in here, if I say gcc dash capital S and then add numbers.c, what happens is that this file would be given to the GCC, but we are telling it to only compile the add numbers.c, and we know that the process of compilation or of compiling is to convert the .c and translate all of them to the assembly code. So if I say I hit enter in here and type ls, you see that another file called add numbers.s has been created, which we could open using the nano editor. If I say add numbers.s, these are the assembly code equivalent to the C code that we wrote, and we actually analyzed all of these things before. But if I say ls-la add numbers.c, you see the size of the file is 110 bytes, while if I say add numbers.s and hit enter, we have 628 bytes. What it means is that, well, this C program is supposed to facilitate our job, right? So we write some lines of codes, but they get translated to a lot of other codes that we could see in the add numbers.s. So we expect that it gets bigger. Now, how much has it been increased? You see it's about 500 bytes. It's larger than the add numbers.c. Now if I want to both compile it and assemble it at the same time, I pass it the -c flag, and then I say add numbers.c. If I hit enter, and now look at the size of add numbers actually let me just first, let's say ls. This ls would show me that add numbers.o has been created due to the execution of gcc-c add numbers.c. If I say nano add numbers.o, well, we wouldn't be able to read this because this is an L file, and we explain how we could read such a file. But if I say ls-la and then add numbers.o, we could see that the size of the file is about 1500 bytes, which is so much larger than the 628 or than 110. And after that we have one last step, and that's the linking. So if I just say gcc, or actually we have created the last one, which is all the assembling, the compiling, assembling, and linking, and the process of add numbers had been created. So if I say ls-la and then add numbers in here, the size is 10 kilobytes, much more than this 1500 or this 110 bytes, even though we know that, well, about 2 kilobytes of that is because of the debugging information. But the thing is that in every step some information is added so that the file well would get to the being an executable that we see in here. All of these things have been facilitating our work to transfer the job or the task from us and give it to the program. So a program like the compiler, assembler, or linker would facilitate our work, but as you see how the size in here changes. Also, you know, if you want to open the add numbers, also, well, you wouldn't be able to do it using the nano editor because it's again an L file and you wouldn't be able to read it. But you could say, I think it would be a good practice if you always try to open all of these files using the x60. For example, I say x60, even though we could open the add numbers.c or s using the nano editor, but what I want to do is to open it using the x60. So this is add numbers.c, which you could see all the ASCII dump in here. These are all the hexadecimal bytes, and the size is 110. If I say x60 and add numbers, or let me open another terminal, and if I say x60 add numbers.s, well, this is the, let me pass it to more. This is another big file that you could see, and as I said, it would be a good practice to compare the bytes between the add numbers.c and also the add numbers.s. And then you could also say add numbers.o. Now you see the file is much more bigger, and it's an L file which you could analyze using the information that we provided for you in the ELF module. If I hit some space, you could see the sections, different sections and different segments. And lastly, if I say just without any dash to see the executable, again we see another ELF file, which, as I said, it would be a very good practice to compare this with the object file, because in this way, if you compare this process in here and the .o, the object file, both of them are ELF files, then you would see how the information has been changed or just added to the file, so that it would be a much bigger file which is able to get executed.